Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So use the ratio test. So press pause and have a go. Okay, so to do this, to use the ratio test, we will need to work out this value here. We will need to get an plus 1 divided by an. So looking at this, an plus 1, well, we've got to put n plus 1 into this n here. So that will then give us this bit here, and then the factorial. And then we've got to put n plus 1 into here. So that will be n plus 1 here, and then you've got your plus 3, and then this n here, you've got to put this into the n here. So that will be n plus 1 here. So your an plus 1 will be this whole thing here, and your an will be this thing here. Now when you get to this stage, have a quick glance. In the realm from 1 to infinity, will this ever be, will it ever be negative? Well, in the realm from 1 to infinity, this will never be negative, this will never be negative, this will never be negative, never negative. So we can discard the absolute sign, and then rewrite this fraction. So here you've got one fraction divided by another. So get the fraction and then multiply by the reciprocal of this thing here. That will then give you this. So that will then take us to here, and then tidy this up. Hang on, bear with me. And then tidy this up. Let me think. Yeah. So this you can tidy this up here. So n plus 1 factorial divided by n factorial. We've seen this many times. So it's like me having one notch higher. So it's like 1 times 2 times 3 times 4, and then n is one notch lower. So it's just like me dividing 2 times 3. These three will cancel out, leaving you with just n plus 1. So the point here is that these two will become n plus 1. And then let's group these two together. So that will then give us this. But then when you get to this stage here, you want something divided by another thing to the power of n. But here you've got this n plus 1 here. Here you've got n. Here you've got n plus 1. So rewrite this as being rewrite it as this thing here to the power of n. So this thing here to the power of n times by this thing here to the power of 1. So this thing here is exactly the same as this. So now notice that these two are the same now. So let's move this thing here across here. So you have n plus 1 over n plus 4. So from here, move this thing here over to here. So you've got this thing here. So this thing here will be this, and then you've got n plus 3, and then well n. Here you've got n over n here. So you can, well, from here that will then take you to here. Okay, and then when you get to this stage here, finding the limit of one thing multiplying another thing is the same as you finding the limit of one thing and then find the limit of the other thing and then times the two together. We've done this from our section on limits years ago. So this here is exactly the same as this. Now if you look at this here, the limit of this as n heads towards infinity would be 1, because the numerator will act as n, the denominator will act as n heads towards infinity. So you've got n over n, which will be 1. So we know this is going to be 1. So we can pretty much forget about this and just concentrate on finding out this. So this thing here, so here you've got one block multiplying with another block. This block here we know is 1. So pretty much ignore this and just concentrate on finding out the limit of this. Well, finding out the limit of this is not so easy. So hang on. So we want to find out the limit of this. So let y be this thing here. So let this whole thing, the thing that we're trying to seek here, let's just call it y, because yeah, let's just call it y. So let's just this is what we're trying to find out. But let's just call it y, and then map a function on top. At the moment, n is discrete. N can only be 1, 2, 3, 4, 5, 6, and so on. It is discrete. Let's map a function on top of this thing here. So we map a function on top of this, and then Now take the natural log of both sides. So not natural log this, natural log this. This will then come down here. That will then give you this. So remember, hang on, let's go back one step. We are trying to seek this. Let's just call it y, and then we try and seek out y. So the reason why we're calling it y is because we want to take the natural log of this. So the reason why we're calling it y is because it makes it easier to explain, hopefully. So take the natural log. That will then take you to here. So that will then take you to here, and then let me think. And then here, so we are trying to find the limit of this thing here now. So here you've got one block multiplying another block. So as n heads towards infinity, this block here will head towards infinity, and then you know that this is going to head towards 1. This thing here will head towards 1. So if you look at the natural log graph, 1 is right here, it's 0. 1 is 0. So as n tends towards infinity, this whole block here, well, you know that this will head towards 1. Natural log of 1 will be 0. So you've got infinity times 0, which is an indeterminate form. So we got to use L'Hopital's rule. So here you've got a product, and whenever you have a product, you use that trick that we've always used in the past. If you want to use L'Hopital's rule, but at the moment it's a product, then rewrite it as a fraction. So rewrite this whole thing here as this block, and then divide it by 1 over x. So basically we are just rewriting this as this. It's just a trick that we've always used in the past. So now let's check it again. We are trying to find the limit of this. So as x tends to infinity, this thing here as x tends to infinity, this thing here will be 1. Natural log of 1 is 0. So the numerator will be 0. As x tends to infinity, this will be 0. So you've got 0 over 0, which is an indeterminate form. So you can apply L'Hopital's rule. So differentiate this. So ultimately we want to differentiate this. We want to differentiate this, and then we want to differentiate this. But before, you could use a quotient rule to differentiate this. But let's remember natural log of a over b. That's the same as natural log of a take away natural log of b. So rewrite this as this. You could use a quotient rule on this, but it's easier to do it like this. So now use L'Hopital's rule, because we know we've got 0 over 0, which is an indeterminate form. So we can apply L'Hopital's rule. Differentiate this. That will then give you this thing here, and then differentiate this. That will then give you this thing here. Okay, and then tidy this up. That will then I will continue in the next video. Okay, we are currently here.